Okay friends, good evening. Today again we are going to discuss about wave equation. So we can think of transmission lines as being composed of millions of tiny little circuit elements that are distributed along the length of the line. That is two parallel conductors with RLC components. In fact, these circuit elements are not discrete but continuous along the length of the transmission line. So we look at a tiny piece or segment of transmission line of length delta Z. This is a simple RLGC circuit model, commonly used model. So this circuit is looks like this. So consider circuit model a small segment of length delta Z or delta Z distributed resistance, L delta Z distributed inductance, G delta Z distributed conductance, C delta Z distributed capacitance. V comma T input voltage, V Z plus delta Z comma T output voltage, I of Z comma T current flowing. Wave equation. Step 1. Now we are applying KVL for this circuit. We can get V of Z comma T is equal to V is equal to at input side I of Z comma T or delta Z plus L delta Z into rate of change of current di by dt of z comma t. So plus v of z plus delta z comma t. V of z plus delta z comma t minus v of z comma t is equal to, from the above equation, minus I of z comma t or delta z minus I minus v of z plus delta z comma t minus v of z comma t is equal to minus I of z comma t or delta z minus L delta z into di z comma t by dt, equation number 1. And now we are applying KCL rule for this circuit. I of z comma t is equal to I of z comma t is equal to, here I of z plus delta z comma t I of z plus delta z comma t plus v of z comma delta z comma t into g delta z plus, so current terms, these are the current terms, v of z plus delta z comma t into g of zt plus c of delta z into dv by dt of z plus delta z comma t. From step 3, from the first equation, limit delta z tends to 0, then v of z plus delta z comma t by minus v of z comma t by delta z is equal to minus ri of z comma t minus l of di z comma t by dt. Next, dv by dv by next dv by dz of z comma t is equal to minus ri of z comma minus ri of z comma t minus l of di by dt of z comma t. Similarly, from equation 2, limit delta z tends to 0, I of z plus delta z comma t minus I of z comma t by delta z is equal to minus v of z plus delta z comma t into g minus c into dv by dt of z plus delta z comma t. So here we can write as di by dz of z comma t is equal to minus gv of z comma t minus cv c dv by dt into z comma t. Consider v of z comma t is equal to re of v of z into e power j omega j omega t, equation number 3. I of z comma t is equal to re into I of z into e power j omega t. Number 4. By placing these equations in step 3, simply we can get dv by dz of z comma t is equal to minus ri of x comma t minus l of di by dt of z comma t. That's why d by dx of re into v of x of e power j omega t is equal to minus r of re into I of z into e power j omega t minus l into d by dt of re of I of z into e power j omega t. Hence these equations will be like this. Re of d by dz of e of z into e power j omega t is equal to minus r into re of I of z into e power j omega t minus l or e of d by dt of I of z into e power j omega t is equal to minus r of re into I of z into e power j omega t minus L of re minus L into re of I of z into e power j omega t into j omega. Hence re of dv by dvx by dz of e power j omega t is equal to re into minus r plus j omega L into I of z into e power j omega t. By comparing the real terms, simply equation 5 will be obtained. Okay. Next, now di by dz of z comma t is equal to minus gv into z comma t minus c into dv by dt of z comma t. d by dz of d by dz of re of I of z into e power j omega t is equal to minus g of re e of z into e power j omega t minus c into d by dt of re into v of z e power j omega t. Hence the equations will be written like this. Hence, these equations, by comparing the imaginary terms and the real terms, um, the equations will be by comparing simply these two real terms, and these equations will be obtained. Equation 7 and 8 are the wave equations of a transmission line. Yes, seventh equation, the equation like this. Sixth equation, seventh and eighth equations are known as equations of a transmission lines.